This video goes over slope. So the slope of a line is a measure of the steepness of a line. It describes the direction of a line and is one of the characteristics of a linear relation. So slope is rise over run, which can also be represented as delta y over delta x, so your change in y over your change in x. Or you can use the formula y2 minus y1 over x2 minus x1, as we'll develop a little bit later on. So in example 1, we're asked to determine the slopes of the following lines. So in order to do that, we need to determine the rise of the line and the run of the line. To do that, we're going to draw what's called a rate triangle. So I'm going to draw across from one point. This is going to form my base of a right angle triangle. And then I'm going to draw up to meet the next point at my next line. In order to find my rise, I'm going to count across. 1, 2, 3, 4, 5, 6. Oh, I lost track. 1, 2, 3, 4, 5, 6, 7. So my run is 7. My rise is going to be the height of that triangle. So 1, 2. My run is 2. So let's go down and we'll fill that in where we have E and F. So my rise is 2. My run is 7. And my slope is rise over run, which is 2 over 7. Let's do the same thing for the other lines. So for AB, I'm going to draw the base across from A and then up to B, and then I'm going to count the squares. 1, 2, 3, 4 for my run. 1, 2, 3, 4 for my rise. So that means my slope is my rise over my run, which is just equal to 1. For the last one, I'm going to draw my right angled triangle between C and D, and then count my squares. So 1, 2 is going to be my run, and 1, 2, 3, 4, 5, 6 is going to be my rise. So 6, 2, my slope is rise over run, which is 3. And now we're going to fill in which line is steeper and which line has the greatest slope. So if I look at the line, I would say that CD is the steepest, because if I picture myself rolling, running, or biking down any of these 3 lines, I think I would go the fastest down C or D. Now if I look at the numbers for slope, 1, 3, and 2 over 7, which is less than 1, I can see that line CD also has the greatest slope. Let's do another example. These slopes are going down, so they're negative. So looking at these, which one do we think is steeper? Probably KL. I think I would roll down that one the fastest. But let's confirm by checking the slope. So we can draw our right triangle underneath the line again. This time it's just to the left. And we're going to count our squares up for the rise. 1, 2, 3, 4, 5. And over for the run. 1, 2, 3. And now I only need to add one more thing. So my line is falling to the left. So if I picture out starting at point K, in order to get to L, I have to go down 5 and over 3. So that means that my rise is actually negative in this case. So let's fill that in down here. I've got negative 5 and 3. That means my slope is rise over run, which is minus 5 over 3. Let's do the same thing for the other two. Draw on my rate triangle. Count my squares. So my rise is negative because I have to go down from G to get to H. 1, 2, 3, 4, 5. So that means my rise is minus 2. Run is 5. And then my slope is my rise over my run. Looking at the last one, I and J, I only have to go down 1. And then I go over 1, 2, 3, 4, 5. So then my slope is minus 1 over 5. So looking at those three slopes, I can say that a line with a negative slope, oh, let's do positive first. We'll summarize there. So a line with a positive slope, like their one's in example 2, they're going to rise to the right. They look like this. Lines that have a negative slope are going to fall to the right. So they look like this. Okay. And we don't need to do those two. Okay. So example 3, now we're going to develop the formula for the figuring out the slope of a line between those points. So the first thing I'm going to do is 3, 2. I'm going to put those points on there, and then 7, 10, because this is the only way that I know how to find the slope right now, is to draw a rate triangle on a graph. Okay, great. So I'm going to draw my line through those 2 points. I'm looking for the slope of that line, and I'm going to draw my rate triangle. I'll do that in blue. Go across. I'll go across here. Okay, so I've got my right angle triangle here. Let's see, my run is 4, and my rise is 1, 2, 3, 4, 5, 6, 7, 8. 8. So I can get that by counting the squares, but I can also get that by looking at the difference between my points. So I'm going to call this point C, and it's at 7, 2. B is 7, 10, and A is 3, 2. So if I wanted to get to 4, I can take away the difference in my x coordinates. If I wanted to get to 8, I can take away the difference in my y coordinates. So that allows me to say, so this is what I have here, but I can relabel that as y2 minus y1, the difference between my y coordinates, over x2 minus x1, the difference between my x coordinates. So my slope of the line is going to be 8 over 4, which is 2. So let's do an example using the formula. So I'll write it again down here. This is something that you should memorize. So y2 minus y1 over x2 minus x1. And the first thing I'm going to do is label my points. x1, y1, x2, y2. The next thing I'm going to do is write out my formula. y2 minus y1 over x2 minus x1. Finally, I'm going to substitute in the values for my points. 1 minus 7 over 15 minus 12. Simplifying that, I get minus 6 over 3, and m equals minus 2. Let's do another one. First thing I'm going to do is label my points. x1, y1, x2, y2. And then what I'm going to do is write out my formula. And then I'm going to substitute in my values. 8 minus 5, 4 minus 3. Tricky double sign there. Then I'm going to evaluate the top, evaluate the bottom, and I'm left with my slope. Let's do one more example to wrap it up before we get on to the word problems. First thing I'm going to do is label my points, x1, y1, x2, y2. Second thing I'm going to do is write out my equation, y2 minus y1 over x2 minus x1. And then I'm going to substitute in my points. So minus 10 minus 8 over minus 4 minus 2. Simplifying that gets me to minus 2 over minus 6, which leaves me with my slope of minus 1/3. We should also be able to apply the rate of change or the slope to word problems. When we're dealing with real life situations, we usually say the rate of change, fancy way of saying the slope. If we're given a graph, we can draw on a rate triangle, and we can measure the run, which is 10 because it's important to consider your axes, and 100, which tells me that my slope is going to be $100 because those are the units of my y-axis, over 10 hours, which are the units of my x-axis, which simplifies to a rate of change of $10 per hour. Let's do another example. The cost of a lunch at Vince's Banquet Hall. So I'm going to choose 2 points that are easy for me to read, and I'm going to draw a rate triangle between those 2. You can choose any 2 that you'd like. My run is going to be 40. My rise is going to be 200. So my slope, or my rate of change, ROC, rate of change, is going to be my rise, $200, over my run, which is people. So then my rate of change simplifies to $5 per person. Finally, we're going to do an example that has a negative slope. And here I'm just going to use the rate triangle from my beginning to end point because those ones are nice and easy to read. So my run is 7, and my rise is actually minus 7,000, which I can get from looking at the labels on my axes. So my rate of change is my rise over my run, and my rise is in dollars, and my run is in year. So then my rate of change is that the value of a copier goes down by $1,000 per year. And those are some examples to wrap up of slope applied to a real world situation where we classify it as the rate of change.